Remember the ACID principle: atomicity, consistency, isolation, and durability. This is a foundational principle of all database systems, if those database systems want to claim that they protect their data. So what we're going to do now is look at how MySQL implements the ACID principles. Atomicity in MySQL is provided by implicit and explicit transactional support within the system. A transaction is a collection of SQL statements. If those SQL statements are executed, they must all execute as a unit to completion, or the entire collection of SQL statements gets undone or rolled back. So it's an all or nothing proposition for the SQL statements within a transaction. A transaction has a lifespan from the beginning or the start of the transaction through the commit of the transaction, the completion of the transaction. Once the transaction is committed, any changes that those statements within the transaction made to the database become permanent. If at some point between the start and the commit of the transaction, some error or other condition occurs that prevents the transaction from committing, all of the statements up to that point are rolled back so that the database is returned to the state it was in prior to the start of the transaction. Now in MySQL, the default is implicit transactions or auto commit, so that if we submit a batch of SQL statements, there will be an implicit start of the transaction and an implicit commit of the transaction embedded within those SQL statements. Within MySQL, we can also set save points. So at some point within the collection of SQL statements within a transaction, we can set a save point and say everything is fine up to this point. If an error or some other condition occurs prior to the completion of the transaction, we can roll back the transaction to that save point rather than having to roll back the entire transaction and then do some other function to either recover from the error or commit the changes up to the save point. So we have save point management keywords, setting a save point with the save point keyword, roll back to save point, and release save point. Now it's important to note, as we've said when we discussed the different storage engines, that transactional support is only provided in the InnoDB storage engine. So let's go look at some code. In this demonstration, we're going to talk about transactions. In doing that, we're going to use the Sequila sample database that's available on the MySQL website. Specifically, we're going to use the film table from that sample database. Before we look at any of the transaction control keywords, let's check on the session variable auto commit. Now the session variable is specific to this connection. We're going to execute show session variable, and we're going to ask to see the auto commit variable. And as you can see, the auto commit is currently on. So we're going to turn that off by executing set auto commit equals 0. Now we can see that we have turned off the auto commit. Now again, this is session only. This is not the global setting for the auto commit variable. If we want to set the auto commit globally for the server, we come to the administration section, system variables, and we can change the value of auto commit for the entire MySQL instance here by saying on or off. Now the default setting is on. I've already changed the auto commit system variable to off. So let's look at the value of a record in the film table. And we're going to look at film ID 52 with a title of Ballroom Mockingbird. The first thing we're going to do is update the title of the film using an incorrectly spelled title. Now notice that we did not execute the rollback statement. We started the transaction, we executed the update statement, but we have not executed either commit or rollback. So the transaction is open and the value has been changed only from our perspective, this connection's perspective. This connection uses the user course local. So I'm going to switch to the local root connection, and I'm going to select the same film, film ID 52, and notice that the title has not changed. It is still Ballroom Mockingbird, even though from our perspective, in our connection with the open transaction, we see Ballroom Mockingbird. So now if we come back to our code and commit the transaction, so now we have told the database system this transaction is complete, make these changes permanent. If we go back to our local root user connection and run this select statement again, we see that now the permanent change of the title of film ID 52 has been recorded in the database. At this point, there is no going back. The change has been made. It's been committed to the database. So we could run rollback at this point and it will do nothing because the change is done. The update is completed and it's been committed. On the other hand, should we now choose to correct this error by changing the title to Ballroom Mockingbird for, again, the same film ID 52, we're going to run this transaction, and within our connection, our session as this user, we see the change, Ballroom Mockingbird. However, going now to another connection, a distinctly different connection by user local root, if we run the select statement, there has been no change to the database because the transaction is open and uncommitted. But from our perspective, our user perspective in this connection session, we see the change. But we've decided not to commit this change. So we're going to roll back or undo the change to the database. So now from our perspective, the value of the title goes back to the prior value, and from the other connection's perspective, nothing changes. The key to explicit transaction control in MySQL is the start transaction command followed by one or more SQL statements, followed by either commit to make the changes permanent in the database, or a rollback statement in the case of a failure of one or more of the SQL statements to undo any of the other changes that the collection of SQL statements might have made to the database. So we start a transaction and we commit a transaction, and the commit is the end of the transaction statement.